Introduction and Overview to Couplers Course 101 Participation Guide Rail Training Assortment. Page intentionally blank. Table of Contents, Module 1, Introduction to Overview of Couplers, Overview of Couplers, Type of Couplers, Coupler Components, Overview, Summary. Module 2, the Schaffner-Berg Coupler, Overview to Schaffner-Berg Coupler, Mechanical Part, Shuffling Coupler, Electrical Part, Shuffling Coupler, Pneumatic Part, Shuffling Coupler, Summary. Module 3, Thomson Coupler, Overview of Thomson Coupler, Mechanical Parts, Thomson Coupler, Electrical Parts, Thomson Coupler, Pneumatic Parts, the Thomson Coupler, Summary. Buckeye Coupler, Overview of Buckeye Coupler, Mechanical Parts, Buckeye Coupler, Electrical Parts, Buckeye Coupler, Error Brake not defined, Pneumatic Parts, Buckeye Coupler, Error bookmark not defined, Summary. Module 5, Operating Coupler, Overview, Coupling a Vehicle, Uncoupling a Vehicle, Summary. Module 6, Inspection, Maintenance, and Tools, Overview, Common Tools used for inspection, maintenance of couplers, and summaries. List of figures. Model 1, Introduction, Overview to Couplers, Outline, Overview to Couplers, Type of the Couplers, Coupler Components, Overview, and Summary. Purpose of Objectives. Purpose of this model is to provide participation within an overview principle of the operation coupler to different type of the couplers used for the rail vehicles. Following completion of the module, participants should be able to complete the objective with the accuracy of 75% and greater. Explain principle of operation couplers, identify different type of couplers, explain the general definition, coupler components, coupler key terms, coupler automatic, manual, Buckeye, Schaffner-Berg, Thomson. Overview to couplers. Couplers provide mechanical, electrical, pneumatic connection between rail vehicles, which allow the train line communication. Couplers may be the automatic or manual. Automatic couplers enable the automatic coupling of the railway vehicles. Coupling of the two units achieved with the manual assistance by drive one unit up to the second. Automatic coupling is even possible if two units horizontal and vertically are not in alignment. The coupler permits couple trains to negotiate vertical horizontal curves, allow rotational movements. Each coupler assembly provide electrical heads to achieve electrical coupling. Uncoupling is done automatically by remote control of the driver cabs, manually from the trackside. After uncoupling separation of the cars, coupler is again ready to couple. Coupler functions provide mechanical connection between two rail cars, provide electrical connection between two rail cars, allows for travel on vertical horizontal curves, allows rotational movement. Automatic coupler uncouple the vehicle with the assistant electro-pneumatic energy process. Automatically couple the vehicles to start with the operator's cab. Automatic couplers have manual option as backup. Manual couplers do not use electro-pneumatic function. Manual couplers are able to couple with the assistance but not require uncoupling process to be done manually. At trainside, this step serves for the automatic manual coupling. Uncoupling vehicles will be discussed later module. Vehicles may use process automatic manual coupling, uncoupling, regardless of the coupling function. Allows the train line communication between vehicles, include door control network, propulsion, and brakes. Figure 1 provide PA8 PATCO, shows front side view coupler location on a rail vehicle. 1-2 types of couplers. This course will cover the three main types of couplers: Schaffner-Berg, Thomson, Buckeye. Although the theory of the couplers is the same, different types of couplers will varying component function. Below, you might have a high-level overview of each type of the coupler. Subsequent modules will be going into the more greater in detail and explain the individual components of the type of the coupler. Schaffner-Berg coupler. Schaffner-Berg automatic coupler is designed widely with a European multiple-unit rolling stock and all types of ranging from the high-speed train with the light rail vehicles. Coupler has a mechanical proportion, pneumatic and electrical connection. Units is coupled to pushing one onto the other. Electrical contacts mounted under the mechanical coupler are protected by cover. When uncoupled, the electrical contacts can be mounted on the side of the coupler. One of the earliest tight coupling mechanism in Schaffner-Berg coupler developed in 1903, which is still widely used. The most serious problem is not very strong, limited to about 1,000 tons, thus only suitable for lower speed passenger trains, not high speed trains, and definitely not freight trains. Alright, this shows your Schaffner-Berg coupler alignment bar, air pipe connection, electrical coupling head, mechanical coupling head, cable connection, shock absorber, and coupler centering device, draw gear. The Thomson coupler was the developed by the Ohio Brass Company for mass transit. This coupler consists of two square metal hooks that engage each other with a large rectangular frame with the airline connections above and below. The Thomson is mostly widely used as a fully automatic heavy rail coupler in North America. Alright, the Buckeye coupler in 1873, Eli J. Janney patented with the knuckle style coupler that was to become the standard for the freight car. Couplers used even today, but the coupler is bifurcated draw head revolving hook When brought into contact with another coupler, would automatically interconnect with its mate. The Jannings coupler had several advantages over Lincoln Penn couplers. Not only did it alleviate the problem loose parts of plagued Lincoln and Penn coupler, it allowed rail workers to couple and uncouple cars without having to go between the cars to guide the links and set the pin. One commentator described the automatic coupling operation as follows: while the cars were apart, the brakeman had to make sure the knuckle of the coupler on the waiting car stood in an open position, where the pin had to be lifted into the set position. When the opposite coupler was closed and locked in position, the brake was able to stand safely out of the way that signaled the engineer to move the cars together. When the knuckle of the coupler of the moving car hit the lever of the arm, revolved the knuckle on the open coupler. It revolved around the locked one, while concurrently locking pin dropped automatically from the set position into the coupler, locking knuckle in place. Although the brakeman had to set up the entire situation by hand, actually the locking operation was automatic and did not require the brakeman to stand between the cars. This shows the jaw, knuckle, hinge pin, and coupler head and hole for the locking pin. Plain view of the standard Buckeye knuckle coupler. The coupler is made with cast steel and jaws moved about the hinge pin for the coupling uncoupling action. 1.3. The coupler components are overview. This section will provide high-level overview of the coupler components, specifically nomenclature function with the discussed later modules. Following table is divided into pneumatic, electrical, and pneumatic components of the automatic coupler component, and the definition of mechanical parts of the coupler. Anchorage device attached to the automatic coupler to the car. Underbody coupler assembly. Centering device position the coupler in center location. Uncoupled end of the car both vertically and horizontally. Draft gear protects the rail car by absorbing energy associated with the pushing, pulling, starting, stopping, coupling. Guiding horn helps guide the coupler into place during the coupling process. The latching device helps latch male and female cones of the mechanical coupler head. Mechanical coupler head ensures the mechanical connection of two vehicles. Suspension holds the coupler parallel to the running rails. Uncoupling device, although the uncoupling of the vehicle allows the uncoupling of the vehicles. Hard electrical parts of the coupler. Coupler controls uncoupling switch, operates coupler release solenoid valve, actuator solenoid valve supplies air to uncouple cylinder rotary switch and actuator. Coupler control cutout isolates electrical signals. Electrical coupler head houses the electrical pins. Electrical head door covers the electrical pins. Electrical pins, electrical contacts which may be fixed or moving. Heater keeps pins dry and prevents from freezing. Line actuator moves the coupler head into place. Proximity switch allows coupler head to move it into position. Rotary switch electrically connects coupler head wiring to car body. Train line cable connects the coupler head to the car body. Pneumatic parts of the coupler. Air filter prevents moisture, debris, and contaminants from accumulating in the pneumatic coupler. Airlines here with the pneumatic air to electrical mechanical coupler. Impulse valve controls multiple valve functions. It means for the pneumatic air tappet valve transmit pneumatic air between the rail cars during the coupling process. 1.4 Summary. The module provides learning with the theory, operation, rail vehicle couplers, a brief history, overview of three coupler type of couplers, Shaftingburg, Tomlinson, Buckeye. Was provided general definition of the coupler components, so also provided can serve as a reference point for future needs. Module 2, the Shaftingburg coupler, overview of Shafting coupler, mechanical Shaftingburg coupler, electrical parts of Shaftingburg coupler, pneumatic parts of Shaftingburg coupler, future of the technology, and summary. Purpose of the objective. The purpose of the module to provide participant overview of the mechanical, electrical, pneumatic of the Shaftingburg coupler. File of the completion module. The participant should be able to complete with the objective of the accuracy of 75% or greater. Identify, explain the function and components of the Shaftingburg coupler. Identify, explain the function and electrical components of the Shaftingburg coupler. Identify and explain function pneumatic components of the Shaftingburg coupler. Key terms: coupler head, latching device, centering device, drafting gear, uncoupling device, suspension attachment, switches, cable, line actuator, valve, electrical pins. 2.1 Overview of the Shaftingburg coupler. Module 2 will discuss the components of the Shaftingburg coupler in an effort to show that all the mechanical parts are related in contact with the module. We'll use line diagrams for the Shaftingburg coupler are used as CATs. And additional photos provided with the Railcar Consortium Members Agency. Figure 2.1 shows the Shaftingburg coupler of the CATs. Module is divided in three sections: mechanical, electrical, and pneumatic parts of the Shaftingburg coupler. The chart below identifies the components will be discussed in each section. Alright, mechanical, electrical, and pneumatic components. Mechanical coupler head, electrical coupler head, tappet valve, latching device, electrical pins, impulse valve, uncoupling device, electrical coupler door, airline, suspension attachment, coupler switches, air filter, and then mechanical and electrical centering device, train line, cable, draft gear, electrical line, actuator. Anchor to device, electrical coupler, heater, alignment components, and coupler control unit. 2.2 of the mechanical parts of the Shaftingburg coupler. Mechanical coupler head with the mechanical coupler head ensure the mechanical connection of the two vehicles with the mechanical mechanical heads of the male-female cone, which allow the automatic alignment over the coupling. The block is outlined in figure 2 of the house of the hook and link. Shows the male cone and the female cone. Latching device for the coupling link hook plate make up the latching device for the mechanical couplers. In case of the coupler hip, the coupled with the protection of the environment. Traction loads are transmitted through the coupling link hook plate and buffer assembly. Shows the link in the hook plate. Okay. Uncoupling device enable the release for the coupler, locks a handle, the lever to cable with the lever. Uncoupling process initiated with the operator's cab pressing with the uncoupled button, and the uncoupling process initiated with the uncoupling motor is powered on all turns of the hook plate. Release the links in the latching device. Main uncoupling can also be accomplished in event with emergency failure with the uncoupling device means the uncoupling handle, which is right there, manual uncoupling handle. Suspension attachment. The suspension attachment is intended with the training for the movement of linear actuator to the electrical coupler. Hold the coupler parallel to the running rails. Consists of bridge, operating arm, latch, and connection shaft. Suspension attachment is located on both sides of the mechanical coupler. Suspension attachment courtesy of CAD. Centering device. The coupler of the centering device is intended with the position of the coupler center location uncoupled with the end of the car both vertically and horizontally, allowing the coupler to remain in a correct position. Automatic coupling happens. Centering device purpose is also to prevent coupler with the swinging during transfer when uncoupled, allow with the navigation of the curves when coupled. Centering device may consist of spring coils, links, and hydraulic shocks. Cushioning device can also refer to as draft gear. The cushioning device for the function protect with the rail car by absorbing energy associated with the pushing, pulling, starting with the stopping and coupling. The cushioning device connects with the coupler fascia for the car body. The main components of the cushioning device include the buffer, the bearing bracket, shear pin, rubber pushing, and shocks, gas, hydraulic. Buffer is connected to the bearing bracket. The buffer functions absorb much of the buff in the draft loads. As part of the buffer cushion compression of the rail car vehicle. Bearing bracket allows the coupler to move horizontal, vertically. Draft gear cushioning device and bearing bracket. Shear pins located on the rear end of the buffer. The maximum shear force is exceeded. The shear pins will show shear allowing buffer to additional compressed. So there's shear pins, buff load, and draft load. Buff load and draft loads are force applied with the coupler modes of the transit, acceleration, deceleration, turning in reverse direction. Buff load and pushing force applied with the coupler. Example, the trailing car is going to want to push the lead car. Draft load is a pulling force applied to the coupler, but draft load, buff, and draft loads are absorbed by the cushioning device. Figure 2.9 shows the example of the buff and the draft forces. Shows the direction of travel, lateral reaction forces, coupler force, lateral reaction force, coupler force, buff forces, directional travel, coupler force, lateral reaction forces, coupler forces, linear reaction forces. In the event of excessive buff forces such as collision load absorbed with the deformation unit, the deformation unit provides protection of the vehicle structure. The deformation unit located with the mechanical coupler draft gear. If collision does happen with the deformation true expand allow the coupler to compress to absorb the excessive force, the deformation unit is not repairable, must be replaced when activated. Deformation, unit courtesy of the BART. Anchorage device out of the rear of the mechanical coupler with the anchorage device consists of the mounting plates of the shear bolts attached with the automatic coupler, unbodied coupler assembly, allows vertical lateral roll movement. In figure 2, the left shows the example of the mounting bolts that can be found on the anchorage device. The anchorage device will consist of the tail eye socket with the draft gear sits on the tail eye socket pivot side to side. Tail eye socket is mounted with the anchorage device. Shows mounting bolts and the tail eye socket and anchorage device. Alignment components. Alignment components of the coupler include a horn referred to as the guiding horn, and the horn is mounted with the coupler head face. The horn helps to increase the gathering range. Gathering range specifically horizontal and vertical with coupling cars possible. The horn helps to guide with the coupler designated gathering range. If the coupling over the curves of the gathering range is reduced, the coupler has also guide pins, guide bushings on its front face to help automatically align the two cars via coupling together. Alright, shows the horn. The male and female cones ensure gathering of the couplers are coupled. The horn helps to increase the gathering range. The diagram provides an example of the gathering range on a straight track. Gathering range of reduced curves, and it shows your horn and your gathering range. Learning application 2.1 gathering range. Help your instructor identify the gathering range of the coupler with a straight track. Afterwards, identify gathering range on a curved track. 2-3 electrical parts of the Schaffenberg coupler. When coupled, the electrical coupler provides electrical train line communication signal between vehicle. This section discusses components specific to the electrical coupler, and after the show how the components relative to the context of the module of the line diagrams for the Schaffenberg coupler use BART, in addition to the provided with the Railcar Consortium members agency. Electrical coupler head. The coupler may have one or two electrical coupler heads. Electrical coupler head houses electrical pins. Electrical coupler head is actuated into place for the air and electric motor. They can also be non-movable spring-loaded pins. The Schaffenberg electrical coupler head is mounted with a suspension attachment mechanical coupler. Figure 2.5 shows the one over the electrical coupler located at the top of the mechanical coupler, electrical pins. Electrical coupler has electrical pins provide electrical contacts located with the insulation block. Electrical pins fixed contacts move the spring-loaded contacts. Flat pins are fixed. Simple rail vehicle communication pins are fixed. The pins wheel with either other during the coupling process. Seal an electrical coupler door protect the electrical pins from the elements environment. Shows the electrical pins. Electric coupler door covers the electrical pins of the car's uncoupled electrical cord. Door opens and closes automatically during coupling and uncoupling processes. Coupler switches, proximity rotary switches are part of the electrical coupler. Assembly proximity switches all allow the coupler head to move the position. Proximity switch tells coupler control system one car mechanically coupled to another. Next, the electrical coupling must happen. Mechanical coupling process initiated. Proximity switch will throw the link and a hook plate into the position so they will be able to latch. Uncoupling process initiated. Proximity sends the signal with the coupler control. The signal system energized with the pneumatic valve with a deactivated uncoupled electrical coupler. After the electrical portion of uncoupled, the mechanical uncoupling process can begin. Proximity switch located on the face of the coupler. Rotary drum switch electrically connected the coupler head wiring and coupler car body train line. Solenoid void is activated. The rotary switch will throw either the coupler or uncoupled of the vehicle. This switch can either electrically pneumatic connect the disconnect, couple, uncouple. Rotary switch is located under the car. So there's rotary switch actuator and coupler electrical isolation switches. Train line cables are connected to the coupler heads of the car body. Train line cables provide connectivity. Electrical signals used to control and operate the train. Train line cables. Electrical linear actuator. The actual linear actuator is mounted on the actuator attachment located to one of each for the side of the mechanical coupler. Advanced retract with the guide pins during the coupling and uncoupling process that move in the headband line. Actuator, electrically actuated pneumatic actuator disconnect with attachment manual operation electrical coupler linear actuator. Learning application 2, electrical linear explain how electrical linear actuator works on trains at your agency. Linear actual electrically pneumatic actuated. Electrical coupler heater. Electrical coupler heaters use the agency experience cold weather. The electrical heater is intended to keep the electrical pins dry and from frozen. Coupler control unit. The coupler control unit includes uncoupling switch, solenoid valve, coupler control circuit cutout. For this purpose, the train with the coupler cutout, coupler control unit will be discussed under the electrical system. Important note: it can be either electrical or pneumatic. Refer to your agency to determine whether the components electrical and pneumatic. Uncoupling switches operate the couple with the release. Initiate the uncoupling operator initiates both electrical and mechanical uncoupling of the coupler. Solenoid valve controls air from the rotary drum switch. Solenoid valve is mounted with both A and B card during complex process. After electrical coupler have the coupled with the solenoid valve to receive the signal that indicates air pressure should be applied to the rotary drum switch. Closes connecting specific train lines to the electrical coupler. Same process happens with the uncoupling process. Before electrical couplers are uncoupled, the solenoid valve receives the signal indicate air pressure for the rotary drum switch. Open. Disconnect specific train line signals. For reaching electrical couplers, coupler to control cutout isolates electrical signal. Vehicle cannot send certain signals from one car to another. Coupler controls cutout is located in the operator's cab. Learning application 2-3 coupler control unit electro-pneumatic. Define control coupler unit switch electro-pneumatic. Place X on the correct box switch provided by the agency specific notes. 2-4 pneumatic parts of the Schaffenberg coupler. Tappet valve. The tappet valve is used to transmit pneumatic air to the railcar vehicles during the coupling process. Impulse valve, the control of the multiple valve function of the means of the pneumatic air. Airlines like pneumatic air to electrical mechanical coupler. Shows the airline courtesy of GC or TA. Air filter. The air filter prevents moisture debris and with contaminant of the accumulating with the pneumatic coupler airline, contaminant of the damage of the pneumatic devices, but not with the limited with the lubricants particle ejected for the compressed for the dirt or particle with the small water droplets. 2.5. The future of technology. Some agencies begin to implement new and innovative Ethernet attachments to even the existing couplers, but do so. It makes transmitting large quantity of the data easier for the Ethernet couple can be attached to the side of the top of the bottom existing coupler. The Ethernet coupler is compatible with both electromagnetic couplers. The coupler is in contactless, therefore it does not cause mechanical wear, creating longer life and cost saving. Alright, 2.6 summary. The module provides participant with a depth of look of the mechanical, electrical, and pneumatic parts of Schaffenberg coupler. Always refer to the specific agencies as nomenclature components functions may slightly differ. Our components: mechanical, electrical, pneumatic, mechanical coupler head, electrical coupler head, tablet valve, latching device, electrical pins, impulse valve, the coupling device, electrical coupler, door, airline, suspension attachment, coupler switch, air filter, centering device, train line, cable to draft gear, electrical line, actuator, anchorage device, electrical coupler, and heater, alignment, components control, computer control, coupler control unit. Module 3, the Tomlinson coupler. Overview of the Tomlinson coupler, the mechanical parts of the Tomlinson coupler, the electrical parts of the Tomlinson coupler, the pneumatic parts of the Tomlinson coupler, in summary. Purposes of the objective of the module to provide participants overview of the mechanical, electrical, and pneumatic part of the Tomlinson coupler. Following the completion of the module, the participant should be able to complete with the objective with the accuracy of 75% greater. Identify and explain the mechanical part of the Tomlinson coupler. Identify and explain the functional electrical component of the Tomlinson coupler. Identify and explain the pneumatic components of the Tomlinson. Key terms: coupler head, latching device, centering device, drafting gear, uncoupled device, suspension attachment, switch cable, linear actuator valve, and electrical pins. 3.1 Overview of the Tomlinson coupler. Module 2 discusses components specific to the Tomlinson coupler and effort show how all the components related with the context module use the line diagram of the Tomlinson with the coupler with the WMATA. In addition, the photos provided with the Railcar Consortium member agencies. Shows the Tomlinson coupler courtesy of the WMAT. This module is divided into 3 sections: mechanical, electrical, and pneumatic parts of the Tomlinson coupler. The chart below identify the components we're discussing each. Mechanical coupler head, electrical coupler head, tablet valve, latching device, electrical pins, impulse valve, the uncoupled device, electrical coupler, door, airline, suspension attachment, coupler switches, air filter, centering device, train line cables, draft gear, electrical linear actuator, anchoring device, electrical coupler heater, alignment components, and coupler control unit. 3.2 Mechanical parts of the Tomlinson coupler. Mechanical coupler head. The mechanical coupler head ensure the mechanical connection of the two vehicles with the mechanical heads of the male and female car and allow with the automatic alignment of the block, which is outlined in red in figure 3. 2 hooks and link and mechanical coupler head. Latching device. Coupling hook and spring make up of the latching device with the mechanical coupler blade and in case of the coupler head when coupled projection from the environment. Shows the hook. Uncoupling cylinder provides the process starts immediately after the command is made within the cab. Pressing of the button on the dash when uncoupling the command is given, the following happens. Linear actuator electrical couplers begin to retract after the electrical coupler fully retract. The signal is given at the beginning of actuation. Linear action mechanical uncoupling mechanical coupler with a fully uncoupled vehicle can be separated. Uncoupling cylinder is located at the top of the mechanical coupler with the receiver. The mechanical uncoupled signal only after the electrical coupler has been uncoupled. Uncoupled devices may also be the handled lever of the cable with the lever of the main arm. Uncoupling can also be accomplished in the event of the emergency or failure of the uncoupled device by means of an uncoupling handle. So this is the uncoupling cylinder and handle. Centering device. For the coupling of the centering device is intended to position the coupler over the central location of the coupled into the car both vertically and horizontally, allow the coupler to remain in the correct position. Automatic coupling happens. The centering device purposes also prevent the coupler to swing during the transition when uncoupled. It also allows the navigation over the curves when coupled with the centering device may consist of spring coils, links, hydraulic shocks. Main function of centering spring with the centering device is to keep the automatic coupler in center position to allow the coupling of the vehicle. Springs are able to be disconnected if needed. Spring consists of the eye bolt connection, length of the chain hook, and attention with the spring of the chain connector. If the coupler is misaligned, exceed the gathering range of the coupler can manually release by way of center springs. Shows the center springs. Cushioning device consists of the draft gear, buffer, bearing bracket, leaf spring holder. Draft gear functions is protect with the rail car absorbing energy associated with the pushing and the pulling and starting with the top and coupling with the main component of the draft gear include buffering, bearing bracket, leaf spring holder, shear bolts. Buffers connected to the bearing bracket. The buffer function is observed with as much of the buffer the draft loads as possible. The bearing bracket allows the coupler to move horizontally and vertically at an attachment point with the coupler underbody anchor assembly. Shift the cushioning device and a shear bolt. Leash springs hold the coupler parallel to the running rail that enable the transfer the movement of the linear actuated electrical coupler. Leaf spring is attached to the leaf spring holder. Leaf spring holder is surmounted with a pivoted shaft. Buffer draft loads. Imagine below show the Tomlinson buffer the under the buffer and draft loads. Buffer the draft loads are forced to apply with the coupler to all modes of the transit. Acceleration, deceleration, turning reverse direction. Buffer load, pushing force applied with the coupler. An example of the trailing car, you the push in the leading car to draft car is the pulling and force applied to the coupler. Example, the lead car pulls away and wants to pull, but the buff and the draft loads are absorbed by the draft gear. Directional travel, linear reaction forces, coupler forces, linear reaction, coupler forces, direction, coupler forces, linear reaction forces, lateral reaction forces, coupler force. Anchorage device. At the rear of the mechanical coupler, the anchorage device consists of the mounting of the plate, shear bolt, attachment, automatic coupler for the car, underbody coupler assembly, allows vertical lateral roll. Move of the anchorage device will consist of the tail eye socket with the draft gear, assist with the tail eye socket, pivot side to side with the tail eye socket, and dismount with the anchorage device. Shift the anchorage device to the tail eye socket with the anchorage device. Alignment components come with the coupler head include the horn. I referred to the guiding horn of the horn is mounted with the coupler head fitted for the horn helps to increase the gathering range. Gathering range specifically horn vertical limited with the coupling of the cars as possible. Horn helps to guide with the coupling with a designated gathering range and coupling on the curve of the gathering range to reduce the coupler over the guide pin guide bushings on its front face to help with the automatic align of two cars that are coupling together. Show the horn courtesy. The male and female cones ensure the gathering couplers for the couples are coupled with the helps to increase the gathering range. Diagram below provides examples of the gathering range, straight track, gathering range reduced on curves. So, lead application 3.1 gathering range help the instructor identify with the gathering range of the coupler straightforward. Afterwards, identify the gathering range of the curve track. 3.3 electrical part of the Tomlinson coupler with the wing coupled electrical coupler provides electrical train line communication signal between the vehicle and the section whether it's with a specific electrical coupler head. Coupler may have one or two electrical coupler heads. Electrical coupler heads housed with electrical pins. Electrical coupler heads are actuated by either in place or air of the electric motor. This constant non-movable spring load pins. Tomlinson electrical coupler head is mounted with a suspension attachment on the mechanical coupler. Electrical coupler header. Electrical pins. The electrical coupler has electrical pins provided with electrical contacts are located with the insulating block. Electrical pins are fixed contacts moving the spring load with the contacts. Flat pins and is fixed. An example of rail vehicle communication pins are fixed. The pins are made each of the during the coupling process. Seal an electrical coupler door protect electrical pins and elements for the environment. This is the electrical pins. Electrical coupler door coupled with electrical pins. Cars uncoupled electrical coupler. Coupler door opens and closes automatically during coupling and uncoupling processes. Coupler switches, proximity, rotary switches are part of the electrical coupler assembly. Proximity switch allow the coupler headed to move in the position. Proximity switch tell with the coupler control system. When one car is mechanically coupled with another, and next to the electrical coupling has to happen, the mechanical coupling process initiated with the proximity switch with a throw link hook plate into the position where they are able to latch. When the uncoupling process initiated with the proximity switch sends a signal to the coupler control system, energizing the pneumatic valve to deactivate uncoupled electrical coupler. After the electrical portion is uncoupled, the mechanical uncoupling process can begin. Proximity switch is located on the face of the coupler. Rotary drum switch electrically connect the coupler head over the wiring. Carbide train line, solenoid valve actuated rotary switch throw over the either coupler or uncouple the vehicle. The switch can either be electropneumatic connected or disconnect with a couple or uncouple the rotary switch located under the car. Rotary switch actuator, coupler switch isolation, train line cables connect, coupler heads to each to the car body train line cable to provide connectivity, electrical signals to the cooperate control they operate the train. Electrical cables, airlines, electrical linear actuator. Electrical linear actuator is mounted on the actuator attachment, which is located one on one over the mechanical one on each of the side of the mechanical coupler. It is advanced for track the guide pins during the coupling and uncoupling process to move the head into place with linear actuator, electrically actuated, pneumatic actuator, disconnect with attached from manual operation electrical coupler. Learning application 3.2 electrical linear actuator with electrical linear actuator training with the trains at your agency with linear actuator pneumatically actuated. Electrical coupler heater with electrical coupler heaters used only with the used agents with experience of cold weather with electrical heater with into the keep the electrical pins and drive from the freezing. Coupler control unit. Coupler control unit include the uncoupling switch and solenoid valve of the coupler control circuit. cut out for a purpose of training with a coupler control unit will be discussed under the electrical section. Important note, be the electrical pneumatic, refer to the year agency to determine whether the components electrical pneumatic. Uncoupling switch operates the coupler release and initiate the uncoupling. The operator initiates both electrical and mechanical uncoupling of the coupler. Uncoupling switch. Solenoid valve control airflow rotary drum switch. Solenoid valve is mounted on both A and B of the car during the coupling process. The air electrical couplers have the coupled with the solenoid valve receives signal indicating air pressure should be applied to the rotary drum switch close with the contact with the train line. Signal with the electrical coupler. The same process happens with the uncoupling process before electrical couplers are uncoupled. Solenoid valve receives signal that indicates the air pressure of the rotary drum switch and disconnects with the train line. Signal reaching electrical coupler. The number of the solenoids might vary with an agency. For example, there are 3 solenoid valve with the Thomson coupler U with the VTA, coupling solenoid valve, uncoupled solenoid valve with a coupler control cutout, isolate electrical switch vehicle cannot send certain signals from one car to another. The coupler cutout switch is located in the operator's cab. At some agency, coupler control cutout may also be referred to perform the same functions as the rotary switch. Learning application 3.3 computer control coupler control unit electro-pneumatic. Define the coupler control unit. Switches electrical and pneumatic. Place X in the space agency. 3-4 pneumatic parts of the Thomson coupler with the tappet valve. The tappet valve U with the transmit pneumatic air between the rail car vehicle. The running coupling process. Tappet valve. Impulse valve. Control of the multiple valve functions needed with the pneumatic air. Airlines control carry pneumatic air electrical and mechanical coupler. Air filter. The air filter prevents debris with the contamination accumulation. Pneumatic coupler air with the contaminants for the damage of the pneumatic device include, but not limited to, lubricant particles ejected by the compressor, the dirt particles, and small water droplets. 3.5. The module provided with the participation more depth look with the mechanical electronic parts of the Thomson coupler. Always refer to the specific agency. Nomenclature component functions may slightly differ. Alright, mechanical, electrical, pneumatic. Mechanical coupler head, electrical coupler head, tap valve, latching device, electrical pins, impulse valve, uncoupling device, electrical coupler door, airline, suspension attachment, coupler switches, air filter, centering device, train line, cable, drafting gear, electrical line, actuator, anchorage device, electrical coupler heater, alignment components, control, coupler control unit. Alright, Module 4, the Buckeye coupler overview, mechanical parts of the Buckeye coupler, electrical parts of Buckeye coupler, pneumatic parts of the Buckeye coupler, summer. Person eject with the advanced model provide participants overview of the mechanical, electrical, pneumatic plan of the Buckeye coupler. Of the following completion of the module, participants should be able to complete with the object with the accuracy 75% or greater. Identify explain mechanical points of components of the Buckeye coupler. Identify explain the electrical components of the Buckeye coupler. Identify explain the function of the pneumatic components of the Buckeye coupler. Key terms: coupler head, latching device, centering device, draft gear, uncoupling device, suspension attachment, switches, cable, linear actuator, valves, and electrical pins. 4.1 Overview of the Buckeye coupler. Module 4 discusses all components of the specific of the Buckeye coupler. The module is divided into 3 sections: mechanical, electrical, and pneumatic parts of the Buckeye coupler. The chapter below to identify the components will be discussed in each section. Mechanical coupler head, electrical coupler head, tappet valve, latching device, electrical pins, impulse valve, uncoupling device, electrical coupler door, airlines, suspension attachment, coupler switches, air filter, centering device, train line, cable, draft gear, electrical linear actuator, anchorage device, electrical coupler heater, lining components, control, coupler control unit. 4.2 Mechanical parts of the Buckeye coupler. Buckeye coupler has 2 major mechanical assemblies: semi-permanent drawbar and a mechanical coupler drawbar assembly. The Buckeye mechanical drawbar assembly. 3 main components of it also affect the mechanical coupler head assembly, drawbar assembly, and yoke assembly. Mechanical coupler head assembly. Ensure the mechanical connection to vehicle. The Buckeye mechanical coupler head is fitted with a drawbar assembly with a coupled with an uncoupled married pairs that absorb the normal broth and the draft loads. This is also an emergency release that observe the force excess of 90,000 pounds. The 3 main components of the mechanical coupler drawbar assembly include the coupler head assembly, the drawbar assembly, and the yoke assembly. The drawbar assembly houses other components of the mechanical coupler drawbar, also allows horizontal movement of the coupler head assembly, allowing it to swing along the radial carrier bar. Drawbar assembles also coupler heads of the remain coupled while the trains moving around the curve. The drawbar assembles also allows some of the vertical of the movement of the yoke assembly. Yoke assembly allows the train to rock side to side with the re-rumber draft gears as part of the yoke assembly. He observes the shackle of the movement of the normal buff and draft loads. Yoke assembly is limited to emergency release ring with the drawbar assembly. Put the draft loads more than 90%, 1,000 pounds per result of the shear bolts shearing to allow for the additional movement. There are 4 total shear bolts. Alright, show the emergency release bolt, chain guide assembly, drawbar assembly, emergency release bolt, uncoupling lever, yoke assembly, guide pin, knuckle, and mechanical coupler. 4.3 electrical parts of the Buckeye coupler. When coupled, electrical couplers provides electrical train line communication signal between the vehicle with the section of the disc component, specifically electrical coupler. Electrical coupler head. The coupler may have one or two coupler heads. The electrical coupler head houses electrical pins. Coupler head is can actuated place in air or electrical motor. This can also be the non-movable spring-loaded pins. Almost an electrical coupler head is mounted with suspension attachment over the mechanical coupler. Electrical coupler has an electrical pin to provide electrical contacts located in the insulation block. Electrical pins can be fixed under the moving spring-load contacts. Flat pins are fixed. Example: the railway vehicle communication pins are fixed. The pins mate with each other during the coupling process. Similarly, the electrical coupler door will protect with the electrical pins elements of the environment. Electrical coupler door. Electrical coupler door is the cover with the electrical pins wearing cars or uncoupled. Electrical coupler door opens and closes automatically during coupling uncoupling process. Electrical coupler door closed. Coupler switches. Proximity rotary switches part of the electrical coupler assembly. Proximity switches allow coupler head to move in the position. Proximity switch tells the coupler control system one of the cars is mechanically coupled to another. Next to the electrical coupling has to happen when the mechanical coupling process is initiated. The proximity switch throws the link and a hook plate into position able to latch. When the uncoupling process is initiated, proximity switch sends a signal. Coupler control system, energy of the pneumatic valve to deactivate the uncouple the electrical coupler and electrical portion of the uncoupled mechanical uncoupling process can begin. The proximity switch is located on the face of the coupler. Rotary drum switch electrically connected to the coupler head wiring with the car body train line. When the solenoid valve is activated, the rotary switch will throw either couple or uncouple the vehicle. The switch can either be electric, pneumatic, connected, disconnected, or uncouple. Rotary switch located underneath the car rotary switch coupler, electrical isolation switches, train line cables connect the coupler head with the car body, train line cover. Cables provide connectivity, electrical signals control and operate the train. Should electrical cables, airlines. Electrical linear actuator is moved with an actuator attachment located in one of each of the mechanical coupler. Advance retract the guide pins during the uncoupling process. Move it into the head and place. Linear actuator can be electrically actuated, pneumatically actuated. It can be disconnected with attachment, manual operation, electrical coupler. Electrical couple heater is one of the used in agencies experience cold weather. The electrical heater intended to keep the electrical pins dry and from freezing. Coupler control unit. Coupler control unit includes the uncoupling switch and solenoid valve of the coupler control circuit. For purpose of training of the coupler control unit, the discussed some of the electrical system. Most important note with electrical and pneumatic referred to the agency to determine these components. Electrical and pneumatic uncoupling switches operate with the coupler release, initiate uncoupling operator, initiate with both electrical and mechanical uncoupling of the coupler. Solenoid valve controls airflow. Rotary drum switch. Solenoid valve is mounted with both A and B cars. And during the coupling process, after the electrical couplers have the coupled with the solenoid valve to receive the signal that indicates air pressure should be applied with the rotary drum switch. It closes and connects specifically train line signal electrical couplers. Same process will happen on coupling process before the electrical couplers are uncoupled. The solenoid valve receives signal that indicate air pressure for the rotary drum switch is open to disconnect speed. Specific train line signals reaching the electrical couplers. The number of the solenoid valves may vary by agency. For example, 3 solenoid valves on a Thomson coupler are used at VTA. Coupling solenoid valves uncoupled solenoid valves. The coupler control cutout isolates electrical signal vehicles that cannot send certain signals from one coupler to the other. Coupler control cutout is located in the operator's cabin. Some agency, the coupler control cutout, it may also refer to and perform same functions as rotary switch. 4.4 pneumatic parts of the Buckeye coupler. The tablet valve used to transmit pneumatic air to the rail car vehicles during the training coupling process. Impulse valve controls the multiple valve functions, meaning pneumatic air. Airlines are like pneumatic air and electrical mechanical coupler. Air filter prevents moisture, debris, with the contaminants accumulation. Pneumatic coupler airline contaminants could be damage the pneumatic device include, but not limited to lubricant particles ejected by compressed dirt or particles, small water drops. 4.5 summary of the module provide participant with a depth look at the mechanical, electrical, and pneumatic parts of the Buckeye coupler. Also refers specifically agency nomenclature components and functions that may differ slightly. Alright, Module 5, operating a coupler, overview, coupling a vehicle, uncoupling a vehicle, summary. The purpose of this part, Module to provide participation process, automatically manually coupling, uncoupling a rail vehicle. Following completion module, the participant should be able to complete with the objective of accuracy 75% greater. Provide automatic coupling for the rail vehicle. Provide automatic uncoupling of the rail vehicle. Provide manual uncoupling of a rail vehicle. Key terms: automatic couple, the manual, and uncouple. Overview. Coupling and uncoupling we can achieve with automatically and manual. Automatic couplers couple and uncouple the system electrostatic energy. The function of the coupling and uncoupling is started within the cab. The manual couplers do not use electrostatic energy. If they're coupling and uncoupling, manual couplers can provide coupled with the assistance. Uncoupling procedure requires personnel to perform uncoupling action at train side. Coupling and uncoupling vehicles can occur with the authorization OCC qualified rail operations employee. The RVS have the couplers to have in good working order. Coupling and uncoupling can occur when it's safe to do so, when couplers can be properly aligned to be for solid buff. Coupling and uncoupling should be avoided on hills and curves when possible. 5.2. Coupling in a vehicle. Procedure for the coupling of a vehicle will vary slightly by agency. Will follow the same of the general process described, but should always refer to the agency specific guidelines before beginning the coupling process. Coupling is accomplished low speed with the system create rigid, fully attached connection between the vehicles. Conduct visual inspection, walk around a stationary LRV to ensure that no blue flags are displayed. Observation presents prevalent. Save coupling visually. Inspect the both couplers ground. Correct the alignment. Readjust couplers if necessary. Verify couplers state center. Open manual couplers ready for the coupling over automatic couplers. And ensure that the key switch to stationary LRV is off position. Stationary LRV is AUX is on. Activate the LRV cab facing stationary LRV. Move the mode selector switch to forward position. Ensure all employees assisting the coupling are in the safe position. That the correct handle signal is given to perform safety stops at 5 feet and 1 feet from stationary LRV before coupling. Ring bell twice before proceeding with the coupling. Master control handle the power position slowly 1 to 3 miles an hour. Bring the LRV together with the meat firmly buffed. Ensure that the coupling is completely successfully observed. The train operated display show with the LRV icons illuminated, confirming that both LRVs are mechanically and electrically coupled. Perform pull test. Ensure that the LRV is securely coupled with a conductive roll test and a brake test within 10 feet of the coupling to ensure the brakes are operating properly. 5.3. Uncoupling a vehicle procedure. Uncoupling vehicle to vary slightly. Agency allow with the general process described below. Be sure to allow always refer to the agency specific guidelines before beginning the uncoupling process. Automatic uncoupling. Activate the cab facing the LRV to be uncoupled. Lift the cover of the uncoupled button to press the push button. Replace the safety cover with the uncoupled button. Move the model switch to the O position. Move the lead cab key up and move the selector switch in the forward position. Ensure employees assisting uncoupling in the safe position. The proper hand signals given and check the motor. Monitors ensure the train is clear with ring bell twice before moving. Move the master control into the power position slowly 1 to 3. Separate with the LRV not to exceed 1 to 2 feet. Ensure the uncoupling is completely successful. Observe the TOD shows only one LRV icon illuminated, confirming both LRVs are mechanical electrically uncoupled to activate the cab. Alright, manual uncoupling. Activate the cab face for the LRV to be uncoupled. Lift couple the uncouple button and press push button. Operating on stationary LRV coupler. Heads pulling uncoupled hand out with a position coupling link. Move the mode switch over the O position. Remove the key and move it to the lever the cab key of the move selector switch forward position. Ensure all employees assisting uncoupling area safe position that the correct hand signal is given. And check monitors. Ensure train is clear. Ring bell twice again. Move the master control handle power position 1 to 3 miles an hour. Separate the LRVs not to exceed 1 to 2 feet. Ensure uncoupling is complete with successful being observed. The TOD shows only the LRV illuminated, confirming both LRA mechanically electrically uncoupled. 5.4. Summary. The module provide participant general process procedure for the coupling and uncoupling coupler. Procedure will be varying. Agency making coupler is important. Always refer to specifically prior material prior to coupling and uncoupling. A coupler. Alright, Module 6, Inspection, Maintenance, and Tools. Overview, Inspection, Maintenance, Tools, view of the coupler purpose. Summary of the purpose of the is to the module of the provide participant understanding of the necessary tool to inspect and maintain vehicle coupler. Upon completion, module of the participant should be able to complete the objectives with 75% greater. Let's explain the function of the tools and inspect the main coupler. Gauges, hand tools, wrenches, digital voltmeter, and lubricant. Overview of the rail car technique of various types. Tools perform door maintenance inspection of the module. Presents some of the common tools used across the assortment of the rail agencies. These models will not go into detail all tools rail car technicians will use the scope of their job duties. Therefore, refer to the agency's complete tool list of tools performed necessary to perform the assigned task. Complete list tools used in the inspection maintenance rail cars. Refer to rail car assortment 100. Alright, show that the go or no go gauge checks all mechanical wear. Height and gauge, check standard height of the vehicle. Tape measure verifies proper height adjustment of the coupler. Grease gun and grease, use lubricant and move the parts. Hand tools, wrenches, screwdriver, the use general maintenance of coupler. Nylon brush, used to clean electrical pins. Torque wrench, used to verify proper nut and bolt tension. Cleaning solution, lubricant, use general cleaning, use coupler, face hook as per operation. Equipment maintenance, digital voltmeter, check for electrical continuity. 6.3 summary of the module provided with a participant list of tools and inspection maintenance, all of the type of the colors in some cases. More specialized than tools needed. Also refer to your agency's with the information full test. Rail car technician will use the scope of the job that can be found 100. Of course, 100.